Welcome back everybody. In this video, I'm going to solve four-digit palindrome problem following the UMPIRE method. So as usually, I copied down the problem statement to my editor. So let's read the problem carefully. Let's call an integer a palindrome if it remains the same after reading its digits from right to left. Given a four-digit integer, print yes if it is a palindrome and print no otherwise. For example, the integer 1221 is a palindrome and we must print yes because it reads the same both from left to right and right to left. Okay, so let's first figure out what given to us. The input, okay, and that is a four-digit integer number. Right, it's a four-digit integer number, and the output is basically print yes or no um, based on the whether it's a palindrome or not. All right, so let's take some of these examples. So first one, and I'm going to grab a few more examples from the test cases. This is also yes, and this is no. Okay, so 8001 and 8008. Okay. All right, so let's consider these examples one by one. All right, so first example, 1, 2, 2, 1. Okay, so let's check now whether we can recognize a pattern in this. We know what a palindrome is. Let's see if we can see a pattern here. If you carefully look, the pattern is evident. So these two numbers equal together. So the first middle two digits equal together, and also two end digits also equal together. Okay. So if we take the, and then this is given, this is a, yes, so this is a palindrome. Okay. So if we take the number, next number, 8001, now if we check the two ends, they are not matching. So this is not a palindrome because as we can see, if we reverse this number, it's not same. So if we reverse this number, this will give us 1008 and it's not the same. Now if we go back to the first example, if we reverse this number, is this 1 goes here, 2 goes here, this 2 goes here, and this 1 goes here, and it's the same. And this is not the same. Okay. Now if we take the second number, I think the same pattern follows. Now they are these two equal, and these two also equal, and this is a palindrome. So if we take this one first, 8, second, third, and the fourth one, and it's the same number. So then what we have to do is we need to match the first digit and the fourth digit, and we need to match the second digit and the third digit. So let's write this down. All right. So let's write this down. What we need to do, basically match digit 1 and digit 2, digit 4, sorry, and digit 2 and 3. Okay. All right. So I think we have an idea on how to solve this problem. So we can go ahead and find a match, and we are checking these equalities. So it's a if else problem, and the one we that already solved, the so the match would be evident that anything that we already solved with using if else, because we need to match two numbers for equality. So the match would be the single positive. One example. Okay. All right. So let's write down our plan. So basically the algorithm. Okay. So first step is we need to collect the input. Okay. Okay. And second, we need to basically extract each of these digit and compare them. Okay. And we can do it in a single line. So what I'm going to do is I'm going to compare the innermost two digit first and then the outermost. So digit 1 and digit 2. So digit 2. So if is 3 and okay, so I check the first inner two digits and digit 1 is digit 4, and if this is the case, so that's my, I'm now inside my if condition, so I would write 2.1, and that is basically print yes. Otherwise, so else 3.1 step print no. Okay. All right. So my plan is clear. So I'm gonna clear my annotations. All right. So let's write our code. So first we need to collect our number. Okay. So equals int input, and then we can write our rest of the code. So if, so digit 2, so now we know how to collect the digit 2, right? So digit 2 is a number. Okay, so we need to collect the mod of 100 first, and then integer division by 10 would give the digit 2, and we need to compare it with digit 3. So that equals, so how do we get the digit 3? Same procedure, instead of 100 we have 1000 over here, we have 100 over here. Now this takes care of comparison of the two inner digits. So now we need to join this Boolean expression using AND, because the two ends also need to match at the same time. So and then I need to compare the two end digits. So the first digit, okay, so it's the remainder of 10. So copy this, change, right, and equals the most significant digit, which is the digit 4, actually comes with integer division by 1000. Okay. All right, so this is our compound Boolean expression. All right, if this is the case, print yes. Okay, otherwise else, print no. Okay, all right, so let's check this out now. Run this. Okay, so I'm gonna input 1 2 2 1. Got a yes. Run again. 8001. Got no. Run again. 8008. I got yes. So it seems like our solution is working. Okay, and that's part of the review process. Okay, so let's see if we can improve this code. Okay, all right, now we joined two Boolean expressions. The first one is here, okay, using AND. In fact, basically AND expect both operand to be Boolean. So in the way that I tested it out, notice I first checked the two inner digits, and that required two operations. So let's count how many operations Python does when we check for this. Okay, so one here, okay, and one here. So 1 2, okay, and then 3 4, okay. So and then we are checking for equality, so there are 5 operations here. Okay, there are 5 here. And if we go check this one, the second Boolean expression, we have one here, and one here. So 3 operations over here. So checking for the two middle digits, it's slightly expensive than checking for the last two ends. Okay, and in terms of optimizing, just a little that we can do over here. Here's why. So AND operator basically returns true only if both returns both operands return true. Okay. Now, when we check the no scenario, basically and returns no in Python and returns false when the first operand become false, because logically we don't need to check the second operand because the first is already false. Okay, so if the first is already true, then Python need to check the second operand as well, because otherwise Python cannot get into a correct evaluation. But if the first operand is false, then it's obvious and it's going to return anyway false because one of the operand is false. Okay, so that means if I swap these two operations, basically bringing the operation that require least number of operations as the first Boolean expression, then in the scenario in which false is the return, Python only have to perform lesser number of operations. Okay, so simply I can modify my plan over here to first check the digit 4 and 1, and then check the inner digits, digit 2 and 3. Okay, and then this has, in the scenario in which we get else, this code generates lesser number of require lesser number of operations. Okay, so it's a slight optimization, very tiny optimization, but it is still an optimization. So this kind of evaluation by Python is called the short circuit evaluation, in which when it comes to AND operator, in the scenario of total return value false, Python only need to check the first Boolean expression of the AND, which is basically the left Boolean expression. Python only need to check that is false only. So that makes the entire expression false. So Python doesn't bother evaluating the second Boolean expression if the first Boolean expression is false. So let's improve our code. So I'm going to simply switch this right here to the front, and that's it. Okay, and I can test again. Okay, all right, so it is run. All right, so there we have it, the evaluation part of the umpire process to improve the code, to optimize the code performance.